Okay, I'm going to do 5 questions from exercise 10.01, probability density functions. So we'll get straight into it. Question 4. Our probability density function has the equation f of x equals x to the 4 over 3355. And we're given a domain, so 2 to some upper limit of that domain b. And it wants us to evaluate b. So the key to all of these questions in exercise 10.01 is the fact that probability density function, the area of that function, or the area under that function, will always total to 1. So the integral, which we know we can measure area under a curve with the integral of a function, dx, in this case is going to be between these two extremities of the domain. So for this question it's going to be between the upper extremity b and the lower extremity 2. That has to equal to 1 if it's a probability density function, always equal to 1. All the probabilities of an event add up to 100% or 1. So all we have to do is integrate this function, substitute as we normally do with integration, let that result equal to 1 and solve, and we should be able to get this upper limit. So let's try that out. The integral of, now I'm going to take out this large number 3355 and I'm just going to integrate x to the 4 between b and 2, and as we know that comes out as x to the 5 over 5. And I'm going to substitute those two in, and if we do so, I'm just going to leave this big number out here just for now. We'll end up with b to the 5 over 5 minus, now if we put 2 to the 5, that's 32 over 5. If we multiply, if we take the 5 out of there, we end up with 1 over 16,775, and we'll end up here with b to the 5 minus 32. So we've performed the integration here, we've performed this left hand side of this function. That result, we now have to equate it to 1. And so if I change my pen here, if we let that equal 1, first thing you would do is multiply by 16,775. So 16,775 equals b to the 5 minus 32. Add the 32 to the other side, you end up with 16,807 equals b to the 5. And now to get b, we'll take the fifth root, or another way to do that on your calculator would be to type in 16,807 to the power of 1/5. That would be the same as getting the fifth root of that number. And when you do that, I'll just change to my green pen, you get the number 7. So the domain for this function, this function, it's x to the 4, so, and it's going to go through the origin, and it's going to look a lot like, if you graph this, it would look a lot like a parabola, and it's telling us between 2 and now we've discovered 7, the area of that curve is exactly equal to 1. So that domain would give you a probability density function. So just remember this for all future questions. That is the essence of each question. You have to take the integral of the function in the domain. That will always equal 1 if it's a probability density function. On to question 5. Given the continuous probability distribution k to the x, or kx to the 3 between 0 and 5, so there's our domain. We could just write that as between 0 and 5, and 0 for all other numbers. So we can, this bit here, we can kind of ignore that, because if we've got a probability function of 0, probability of anything that's 0 is impossible. And so we're going to ignore that. We're just in this domain here. Find the value of k. So this question pretty much becomes in the domain 5 to 0. We're going to integrate, I'm going to take the k out. Kx to the 3 dx. I'll leave the k out there. Oops, between, so that become x to the 4 over 4 between 5 and 0. And if we Substitute values in. 0 won't give us anything, but 5 to the 4 is 625 over 4. And as I said before, if this is a probability distribution, that whole thing is going to be equal to 1. So I'll just cross out that equal sign for now. When at k, we've got this fraction here. We're going to move it over to the other side, and essentially we get the final answer that k is equal to 4 over 625. Okay. Hopefully this is making sense now, and if it is, you might want to skip the video and go and try 6 and 7, but I'll quickly do some anyway. We'll do a from 6 in the domain 1 to 3. What's the value of a? So what coefficient would this function need in order for it to be a probability density function? Okay, so between 3 and 1, we're going to integrate a e to the x. Now remember, this is e to the 1x. And the cool thing about that function is when you integrate it, when it's got a 1 in front here, the 1 will go underneath here, so essentially it will not change. If this happened to be a 2, we would get a over 2. It would be a slightly different function, but I'd say they put this question in deliberately because this will not change. And if we substitute in there, I'm going to take the a out. We're going to get e to the 3 minus e to the 1. We can take e to the 1 out as a factor there, so I'll take it as, and if we factorise there, we'll get e squared minus 1. And because it's a probability density function, what we're assuming it is, we'll let that result equal 1. I'm just going to pop it there. We're after the value of, we'll find the exact value of a. So here's a. I'm going to take all of, oops, just changing the colour of my pen. I'm going to take all of this section here, divide this right hand side by that, and so we end up with a is equal to 1 over e squared minus 1. You know, we've got a difference of 2 squares there. You could make that e minus 1, e plus 1, but I'll just leave it like that. Going back to that one, yeah, try B and C yourself. Question 7, we've got a function here, x squared over 72. Over what domain starting at x equals 0? So it's given us the left-hand bound there. Would give us a probability distribution function. Let's call the upper limit there b. You don't have to do that, but I'll just, because we've got the variable x here, I'll call this b, because in integration you might recall the domain is usually from a to b. So what is the value of this b? So between b and 0, I'm going to take the 1 over 72 out. We're going to integrate x squared. We know that becomes x cubed over 3. Between b and 0, and all we have to do is substitute in, let that equal 1. I hope this is becoming pretty straightforward. I'll take the 3 out there, 1 over 216. Put b in there, we're going to get b cubed. Put 0 in there, we're going to get nothing, so we get this result here. If we let that equal 1, we want to get b multiplied by 216, so we get 216 equals b cubed. And if we take the cubed root, or to the power of 1/3, what did I get before, just so I don't make a fool of myself? That would be 6. Okay, so this domain here, if we integrate between 0 and 6, we would get the exact area under that curve as being 1, and that would give us a probability distribution. On to the last question in this video. You might have seen in some of the questions PDF, which we know is an Adobe document abbreviation, but in this case they're meaning a probability distribution function. I hope that made sense there. Is given by this quite a large number. Now you'll find that they use these large numbers because you're going to end up taking, in this case, probably the 6th root, because we're going to integrate, that'll be to the power of 6, and the 6th root of these large numbers comes down to quite a small number over this domain, which we could interpret like that, and I hope that's becoming more familiar to you as notation for domain. So let's do this. The integral, take this big long number, 87381. We're going to integrate 2x to the 5. That's going to become x to the 6 over 6. 2x to the 6 over 6 will become x to the 6 over 3. If we multiply, oh, I've left a number off there. If we multiply those two together, we get this rather large number, 262,143, and that'll be times x to the 6. Now if we substitute what were our domain was between 1 and b, and if we put those in there, we would get b to the 6 and minus 1 to the b to the 6 minus 1 to the 6, which would just leave us 1, and that's our result. That's the result of that integral. If it's a PDF, we're going to let that equal 1. Getting quite messy now. Let's solve this for b. If we multiply that, we get 262,143 equals b to the 6 minus 1. We're going to add 1 to that, make that a 4, and the 6th root of this, if you type that into your calculator and do it to the power of 1/6, you'll get the result of b equals 8. So this domain here, between 1 and 8, if we graph this function and found the area between the x-axis and this function, it will come out as exactly equal to 1. And that's at the heart of this first exercise. I hope that makes sense and can help you get over the rest of the exercise. I will try to make a similar video. I will make a similar video for some of the questions for 10.02. See you next time.